Okay, sorry, I'll just fix this up. Okay, now these are instructions for today's lesson. So after you've just watched that video, we're looking at exercise 1D, differentiation of inverse trig functions, just some Cambridge questions. Now this is very similar to one of the questions I just did in the previous video. It says show that the derivative of this function, inverse sine of x plus inverse cos of x, is 0. That just means show that this graph is flat, that it's a straight line and that its gradient is always 0, so it's flat. So therefore, the function y equals inverse sine of x plus inverse cos of x, because it's flat, we'll go crossways like that. It'll be a straight line graph that's flat. And straight line graphs that are flat like this are, for example, like y equals 1 or y equals 2 or y equals -1. So this is saying explain why it must be a constant function. That will be because the gradient of the curve is constant and it's 0, and therefore it'll be of the form y equals some constant, okay? And then it says use any convenient value of x in the domain of these functions to find a value for that for the constant. Well, girls, you just choose any value. I'd probably choose pi and 2, because reason is, if you look at inverse sine of x, its domain is from negative pi and 2 to pi and 2. And the inverse cos of x, its domain is from negative pi and 2 to pi and 2. So what I do the values of negative pi and 2, substitute it into both of these, into the normal function. And I'd also do the value of pi on 2 and substitute it into the normal function, because we've just got to make sure there's no discontinuity, and there shouldn't be with this one, because all values of x, for example, there's not a 1 on x here that makes it undefined, okay? So we're thinking inverse sine of pi and 2, if you can sort of remember what that is, or of, yeah, the inverse sine of pi and 2. I'll just get my little sheet out, sorry about this mess, and we'll have a look. So let's draw the sine curve. So it looks like we might have some different values. Oh, sorry, that's -1, and that's 1, and that's pi and 2, and that's negative pi and 2, okay? Now the inverse sine of negative pi and 2 is -1. Sorry, I mean to say that the other way around. The inverse sine of -1 is negative pi and 2. But look, if you want to check inverse sine of -1, see, if you want to do that, what I'd rather you do is say if y equals inverse sine of -1, then the sine of y is -1, and that makes you look at the normal sine curve. So the sine of what is -1? Well, it's the sine of negative pi and 2. All right, so just be careful the way you read these. It's not the way that you read the normal sine graph. You've got to read it sort of in reverse. So the inverse sine of -1 will be negative pi. Well, y is the inverse sine of -1, so it is, which is negative pi and 2. Okay. Okay, so we know that going back to that question, and we wanted a value for the inverse cos. Just one sec. If y, the inverse cos of -1, well, that's pi. So you can't even see it. So let's just, so we've chosen the value of -1. The inverse sine of -1 is negative pi and 2, and the inverse cos of -1 is pi. So if you want to do the inverse sine of -1 plus the inverse cos of -1 for that graph, and you want to sketch it, you've got negative pi on 2 plus pi, which is pi on 2. So we know that the gradient of the curve is constant, it's always 0. And we know that when x is -1, that y is pi on 2. So you're going to have your curve is going to be pi on 2. That's what your graph's going to look like. It's got a gradient of 0, and it passes when x is -1, y is pi on 2. I mean, you can even look at another value here. Sorry, this is really messy. the inverse sine of 1 is pi and 2, and the inverse cos of 1 of the normal 1 is 0. Pi and 2 plus 0 is pi and 2. Again, when x is 1, the curve is sitting at pi and 2. Okay, so that's how you do that first question. So you can do that, and then you can try these ones as well using that method that we've just used above. Try maybe just do 6a. Okay, you don't have to do 6b. All right, then you be good to, a good idea to do questions 7a and b, and you can try this question here. You'll have to use the quotient rule to differentiate in question 8. Here's some more practice for you to find derivatives in question 9. And question 11, you can have a look at that. Question 14, you don't need to do, because that was actually one of the questions that we just did in your textbook. We actually sketched this function, okay? I think it was question 10. And you might try question 15. I wouldn't worry about question 17, okay? So you can try and differentiate these functions. Anyway, have a go, okay? All right, and that's it for tomorrow's lesson. So you'll be very busy. And it will be a bit challenging, so I just suggest that you all help each other.